Imagine that you have a problem where you're able to establish what the total of each characteristic is. So you will have the total of the rows, the total of the columns, and the rate total. But here, there's no way you can find, just by knowing the totals, all of the intersection unless they give you at least one of them. If you are not given any intersection, then you cannot establish the real values of the intersections, but only ranges of values. You can establish what's the minimum value, what's the maximum value for each of the intersections. Let's say in this problem, we want to find the range for this intersection. So finding the max value and minimum value for those who have characteristic B but not A. Okay, how would we do this? Let's see here, people. It's very easy. First of all, pick the values that correspond to the total of each column and row where your intersection is. So for example, X is part of row B and part of column not A. So we know that this count, X, cannot exceed any of the totals. So its max value should be 20. The max value of the intersection X should be 20. So you can write here a little something. The max value of a box is simply the minimum of the column total and the row total. Let's now talk about how to find the minimum value of X. Well, it's not always 0. Remember that the intersection counts, they always represent positive integer values or 0 in the worst case. How can we find the minimum value of X? Since, for example, the sum of square box Y and X is fixed, is 20. So it follows that this sum is a constant value. If you want to minimize the value of X, that means that Y should reach its maximum value possible. In this case, what we need to do is find the max value of Y, and since that added with the minimum value of X should be 20, then it follows that the minimum value of X should be 20 minus the maximum value of Y. So, take a look, people. What is the maximum value of Y here? If you just follow the directions in the previous slide, you just pick the least value of its two totals, that is 10. So, perform this subtraction, 20 minus 10, and you get also 10. So, the minimum value of X equals 10 as well. You can do that also using the box C.